Good morning, everyone. Uh, I am glad to be here today and discuss about database patching at scale. Uh, and it is great to interact with you all today on this Noku session. So, so today we are going to talk about database patching at PayPal. So, what are our unique challenges? What patching methods we explored and what we used eventually, and some of the techniques and some of the products we came up with over the period of time to achieve close to zero downtime patch. And we will follow up with some question and answers. Um, so later. Okay, let me introduce myself. My name is Pramod, and I'm part of database engineering team at PayPal. And overall, I have 15 plus years of experience with Oracle technologies. So I am very passionate about a few areas in general, like Oracle Golden Gate replication is one of them, and then I spent a lot of time in developing highly scalable and available applications here at PayPal as part of database engineering
Looks like we lost Pramod.
team and managing software. So that is another area of my interest. So you can reach me on my LinkedIn in case you want to kind of get in touch with me on any of these topics later. And I'm really interested in discussing these topics even out of this session. Okay, let's. We all know PayPal. We all use PayPal. So this is something our founder started with the vision of keeping economic power in the hands of the people. So our mission is to democratize financial services for everyone in the world. So the key part here is we operate in across many countries, and we have like 400 plus million customers on our platform, um, and 20 million merchants. So we are a two-sided network, and then we play different roles in the payment ecosystem. Like we are payment processor sometimes, or we might be a gateway. Or we play different roles, and we are expanding into uh, new avenues. So you might have seen many new products from PayPal. So we are still growing, and then we are also expanding, and we are also modernizing. So that is the key. And we are a global company. That means uh, so things are we deal with variety of problems, right? So variety of challenges, variety of audit requirements. So those are our challenge, and this is our scale. Like as I mentioned, like 400 plus million customers and 20 million merchants. So all of them expect a lot from our infrastructure, and we strive to maintain high availability and secure environment for our customers. So what does that mean to us, right? So I already mentioned like the global scale of PayPal and the scale that we operate. So these are some of the numbers we see on our database platform as a result of that. As I mentioned, uh, we are still growing. So we see like 33% year over year growth on the storage side. And we see like 6 million plus executions per second on our platform. And we have like 750 plus Oracle database instances to support all of our business requirements. And overall, we have like 90 plus petabyte total database storage in our data center, right? So the growth is translated into number of database hosts, the compute growth, storage growth, and everything. But specific to the maintenance and software maintenance or software lifecycle management, This is one thing you can see. The number of hosts, database hosts, and the scope today is Oracle database host. So that is growing over the years. As you can see, now we crossed like more than close to 600 database hosts. And I'm only talking about some variety of database hosts. Maybe I'm excluding some standby databases and all of that. So what triggered this growth? So as I mentioned, organic growth is obviously the number one driver. So from years we have been growing. And if I compare the infrastructure, like almost back in the day when I joined, so we used to have like 200 database hosts at that time. And then over the period of time, now we are like almost tripled or even more if we include standby database hosts as well. So another important driver is horizontal distributed systems. So John mentioned in his presentation how we scaled over the years by scaling out. So scaling out gives you the opportunity to scale and cater your customers, but at the same time, it will increase the fleet size. It will increase the number of databases you need to handle. So that is a challenge for every DBA or any admin or anyone who is working on the infrastructure in the backend. So another thing that happened is consolidation is one of the things that helped us a bit. Like starting 19C, we started using 19C and especially pluggable databases and multi-tenant consolidations we were able to leverage. And we were able to reduce the number of database hosts to an extent. But at the same time, the number of times we have to patch our systems has gone up. So there are a variety of reasons for that. So there are strict audit requirements, and as we scale across the countries, every country has their own audit needs. Compliance rules are different. So the frequency is one of the requirement today, and not only from the auditors, but also from the stability side, resiliency side, infrastructure side. As we move along to 19C, there is more agile patch development from the Oracle itself, and then there are more fixes we are getting on the fly. So the bottom line is we are doing patching our systems more frequently. So I'll give some details on that, but over the period of time, so this is what caused the growth. And we are looking at around 600 plus database hosts to patch. So now how do we scale, right? So if we're talking about less frequency and then more number of database hosts to patch, so we are talking about 3x times of patching or 4x times of database hosts if you consider like patching every quarterly. So that is like thousands of patching like in a year, right? And not only from us, not only for us. And if you look at one of the recent articles released by Oracle, so Oracle, you might be aware, like MAA is Oracle availability model, and then the feedback they got from the customers in that area is the number one pain point for Oracle customers is upgrades and patching. So you can imagine the need to modernize, automate, scale to keep up with the growing variety and then number of hosts. So I would like to highlight database software lifecycle here, like for specifically Oracle, what we do. So we do a few things uniquely, and also like there are several things unique in each phase of software lifecycle management paper. And ultimately, our goal is to create a secure environment and highly available environment. There is no room for any downtime. And then we should be able to scale. There should not be any performance bottlenecks. So all our software should be powered with all the performance fixes from the vendor and also something engineered by ourselves. So that is our target. And then if you look at the software lifecycle management, some of the unique things we do are, so if you look at the build, so for example, typical life cycle of the Oracle software is like we get PSU or RU every quarter, right? So I will dissect them and I'll explain like what are those like for those to give some more background. But basically, let's say like every quarter you get a patch set. And what unique about our environment is we have a lot of fixes added on top of that PSU. Okay, let's say PSU for the simplicity, and then or RU for the simplicity. So for each and every RU, we request Oracle to merge a lot of fixes specific to PayPal. So just to give you an example, like last RU, we added 25 plus fixes. Those are all specific to Oracle, like based on our environment, whatever issues we faced in our environment, and whatever scaling or performance fixes we requested. So, and this continues. Like this is only for one RU. So now if you look at, uh, let's say like if you take a 11G version, and then if you think about all those number of fixes we might have added over the years, there are hundreds of fixes we might have added over the years, and then lot of performance optimizations we requested, and then there are a lot of parameters specifically designed for PayPal, a lot of enhancements requests. So that is something unique. So so every time the build phase itself is unique, the start of the cycle itself is unique. Like we work very closely with Oracle to get our own MLR merge label request, and then basically that is whatever is released by Oracle for the clients, plus a lot of all these enhancement requests or hot fixes and whatnot. So now then once we get the patch, so other things we do is we certify the patch, we document very clearly what are the changes in this patch set, what are the parameter changes in this patch set, all of them we document it very clearly. And then we also test the new patch set, right? So the regression is very common with any new patches. Like for example, like you get a new RU, and then that RU might introduce some new regression fix, right? So basically, we may need some regression patches to address them. So we, uh, as part of certifying the new patch set, we apply our MLR we got from Oracle specific to us in a test system. And then we run a lot of performance tests to test the resiliency on the database side, compute, storage, interconnect everywhere. And can it address some of the issues we faced in the past, or uh, are we still holding on to the fixes we got in the past? For example, we may have some specific paper fix in the past, but now in the new release that might have been missed, right? So all these things we do and prepare our cold image. So I will again like discuss that in detail, and then we deploy them to the number of hosts I mentioned, like 750 plus DB hosts. So we need some automation there. So how we are doing it, I'll discuss. And we have dashboards, and we do some audit to report uh, how compliant we are, like how latest we are on all the database systems, and are we lagging on any of the database systems. Like all that reporting and auditing capabilities are there, and it is absolutely reviewed all the way up. And so there are action items based on that, and we need to keep continuing to comply with. And again, as I said, reporting the new bugs, this cycle continues. Now I got the new fix. For example, especially if you talk about the latest versions we have been using. At 19C, I got RU10, RU11, and then we started using them, and we definitely come across a lot of new bugs every now and then, a lot of new fixes, enhancements, and we constantly discuss how we have to scale our infrastructure, and then based on our learnings, we request some proactive fixes. So this cycle continues, and at the end of the day, as I said, like we want to make sure all this packed, uh, we can say gold image or software is deployed across the board for high availability, scale, and security. So now I think John touched upon this briefly in his session. So basically, we scaled out our architecture over the years. And this is our typical deployment pattern. And this is in one region. So just to give, it can be more complex and it can be more simple, but just to give you an idea. So basically, we have read-only replicas, and also our read-write traffic is sharded based on keys, some of the things John mentioned. So it is sharded, and we use Oracle RAG services. And each of these cylinder you see here is a RAG database. So each of them can be a 3-node RAG, 4-node RAG. So you can imagine. So now in a region, you might be looking at so 20 database hosts or 30 database hosts per single family, right? So for a single family of database, we have like 30 odd databases, and then it is replicated in another region for disaster recovery purposes. So now you can imagine. So now why is that growth, and what is the scale in our environment? And as we mentioned earlier, so we also split our domains, and we did not have everything in a monolithic database. So we keep on isolating them, and each of them will have this kind of pattern. So that explains why there are so many database hosts, and it will keep growing. And on the right, you see the scale. So right, I mentioned some numbers here. So we are looking at on some databases, basically these are the highlights. And some databases we are looking at 300 Mbps redo, and then 50K write IOPS, 50K read IOPS, 100K per instance executions per second on a particular node, one single node, right? So this is just to give you a scale. So now how does it matter when you talk about patching, right? So one part I already mentioned. So so this is how we are getting more number of hosts, and there is explosion of number of database hosts we have to patch. That is one part of it. Other part of it is whatever you do in the whole environment. For example, if I'm patching one particular database, it's not about dealing with that particular database. You have to be aware of everything happening in that whole family. For instance, I have 3 replicas here, 3 read-only replicas here. And if I want to patch one particular replica, and let's say I have trouble with other 2 replicas due to performance issues, or there is some other maintenance going on other 2 replicas, obviously I cannot patch this one, right? So that is where there was a need to come up with a lot of unique um, patching products, which are really aware of the full fleet, full group of the database, like all these databases, what is going on there, performance-wise, capacity-wise, all this, whatever product we come up with should be aware of all of that knowledge, right? So otherwise, it cannot be anonymous and it is manual, even though we have some products, some tools. Without that knowledge, it cannot be anonymous. It cannot be autonomous, and then you cannot achieve your goal. Okay, so now I briefly mentioned PSU, RU. I wanted to touch upon these things. So I think it is little kind of need some clarity with all this naming convention Oracle is coming up over the years. So in 11G days, we used to have PSUs, and then CPUs are also there, CPUs, and then PSUs, and then bundle patches. They'll come to 19. But when I talk about 11G, so PSUs are basically bundle of security fixes and then regression fixes. Fixes are something which was working before and then now it is not working, right? So this basically fix actual bug fix. So now every quarter Oracle releases a PSU that is actually a combination of regression fixes and security fixes. They also release CPUs. CPU is kind of only security fixes, but that is subset of PSU. And they also have bundle patch concept. So bundle patch is superset of PSU. And basically it contains few other fixes like optimizer fixes, functional fixes. Functional fixes can be feature enhancements as well, right? So basically in 11.2.4 itself, we may ask some enhancement, or Oracle want to bring up some new feature, a small feature. They can put it in a bundle patch and give it as a fix actually. So all that was 11G terminology. And starting policy and 1819, you might have been hearing concept of RU and then RUR. So RU is release unit. So RU is equivalent to bundle patch in the 11G. So basically, it has all those fixes, regression, security, and optimizer fixes, functional fixes, all of that bundled together. And you also have an option to apply RUR. RUR is a revision to RU. So basically, RUR will have everything uh, a new RU has, and then basically it is an extension to previous RU. So in this example, for example, if I take this 19.2.0, 19.2.1 is an RUR. This is a revision to 19.2.0. All the fixes up to this quarter, security fixes, performance fixes are included here. But RU on top of it will have, again, this optimizer and functional fixes, like in addition to RUR, it will have some more fixes. So at PayPal, we go in RUs for 19C. So we have 19C and then 11G deployments. So for RU, so we try to patch every quarter. And then again, like after each RU gets released, we get a lot of hot fixes. So those gets included. And then we have to keep refreshing our images, right? So I call this software to be placed on the target servers as image. I think most of you are familiar, like that is called goldimage even by Oracle. So these gold images gets refreshed every RU for sure. And also within each RU, whenever we get a new fix, we have to refresh that particular RU. And then we have version 1, version 2, RU9 version 1, RU9 version 2 and all. So now the complexity is more, right? So we already discussed the number of database hosts and then frequency. Even if you take quarterly patching, it is already a lot of patching, a lot of number of maintenances. So now on top of it, if there are any revisions, so we may have to go back and patch again. So whatever we want, that should be extremely flexible, and then should be extremely scalable, and then should be able to address these issues at scale. So now we started exploring as the need is growing up. So we started looking at our patching practices, exploring things, and then trying to find out something optimal for us. So so there are a few methods available already, and so that is what I'm going to discuss here. So basically, in short, we have two patching concepts available for Oracle, and this is their terminology. Basically, there is something called in-place patching, and there is something called out-of-place patching. In-place patching is, again, you stop your services in place, and then you will patch in place. So, for example, if you have a software directory called, let's say, like /home/19C, and there are databases running on that software directory. So now the in-place patching is basically you stop those services, you stop the database and patch in place. And again, like obviously, it is very obvious. We cannot take down all the systems and do it all the time. So in the modern systems, we cannot do this. Now, out of place patching is so you prepare a new image in one way or the other. I'll discuss there are several ways. In one way or the other, you prepare a patch system, pre-patched software image, and then you can switch it to the new software image. This is out of place patching, and yeah, we explored a ton of all the features out there, and as I said, our requirements are really stringent. So we had to explore each and every concept and wanted to come up with something flexible, something scalable, and these are some of our observations. So I will talk about these things in detail, but at high level, we have, uh, I would say, like two utilities at high level, and then there are products on top of them. So just to summarize, like Opatch is, every one of us knows what is Opatch. It is the oldest patching, Java-based patching utility Oracle has. All it does is you will input a patch directory. It will take the changed files, change binaries, and it will place onto the target software directory. So now the new developments there is something called Opatchauto. And starting policy, the aim of Opatchauto is to orchestrate and do patching, dealing with conflicts. Even there is an extension to stop the services, stop the databases, and all of that. So that is an option. We'll discuss about that in detail. There is something called grid setup. Grid setup is equivalent to run installer for or RDBMS. So basically, it is an installer product, and then there are extension to perform patching in that. So this is the key distinction in my in all my exploration. This is what I found out. Basically, Opatch is a patching tool, and there is an extension to orchestrate grid setup, run install, or the installer products, and then there is an extension to patching them. So I'll talk about that in a bit. And then there is FPP. FPP or RHP basically leverages all these products and then does some orchestration for you. And there are some pros and cons. We'll go through that. And now we'll also talk about our methods after exploring all these methods. So still whatever we used to do over the years is still relevant and very flexible. So we'll talk about it, which can be good for some of you based on your environment. So now Opatch, I mentioned Opatch. So basically, extension to Opatch is Opatchauto. Within Opatch, there are a lot of new enhancements, like you can apply multiple patches, and then there is an apply, and rollback, and all of that is there. But Opatchauto takes that to the next level. So there is an orchestration layer within Opatchauto. So that will do pre-patching tasks for you as well. Like it will stop the services, and it is supposed to basically look at the conflicts. And if you just input one patch set, it is ideally, it should look at the conflicts and resolve some of the conflicts on its own, unless it is really complex. And then it will also start the services. It is also aware of rack and all of that. But the downside is obviously, as I mentioned, our patches are really complex. So we have like hundreds of conflicts. So for example, if you take here, so this is one of the testing we did. And I try to use I try to apply a typical RU released by Oracle, right? So nothing fancy. That RU we try to apply in our environment. And then even though there are options to, like I mentioned, the flags, like there is something called handle conflict. So even with that, it could not handle, and there are so many conflicts, right? So the downside is it works for simple patches, not for complex patches. And the orchestration it does is really minimal. Like if you have a lot of big logic, like what I mentioned, like if you have to move the connections, if you have to be aware of your environment, all of that level of granularity is not there. And there is no provision for, not a lot of provision for some of the customizations you can do. There might be some, but not a lot of it. And this is truly local. You have to go to the target host and then you have to execute. So you cannot do it from the central location unless so really limited to local, and the scale is limited. Basically, scale is limited. The patch sets it can handle is really, really limited, and something not for us. Just as an idea, like this is how it manages. So the new patches are being released in this format, like system patch format, and it has this sub patch information and all of that. So the Opatch tool looks into this XML file set. That is how it does. But again, not for us. In some cases, it may work. Depending on your environment, it's worth giving it a shot. Now, the next one is grid setup tool. And as I said, this is actually an installation tool, but there is an extension to apply patch, and then there is an extension to switch the homes. All of that is added. And internally, all of them uses legacy products, legacy scripts like clone.pl, and then root crs.sh. There are some traditional scripts. A lot of hands-on DBS knows those scripts, so it uses all those products. But the key distinction here is these are basically, this is an installation product, and then there is an extension for patch. So now these are the options. Now you can say like apply RU, and then you can view the RU number. It can do it for you, but again, not for us because there are a lot of conflicts. And then you can create the gold image, right? So now this is your input. So the gold image here is just the pack of binaries. It will not have anything specific to the configuration. So for example, if I am creating gold image on a lab server or basically any test server, so all it does is it extracts the binaries from that new software location and packs it, and that is your gold image. The expectation here is you take that gold image and apply anywhere in the target. The expectation there is you use some of these tools to perform the cloning, right? Cloning meaning, so basically, so now this gold image has the binaries. Now, if I take to the target system, it is it does not. There is nothing specific to the environment, right? So there are no files specific to the environment in this gold image. You cannot just operate this one. So then you have to leverage these tools. Like now you can do either switch grid home, right? And then there are some custom options to do cloning. So basically, all you are doing is you take these binaries to the target, and then from the target system, you get that configuration and put it into your new image, and then that is your full image. So that is the concept. And then the downside of this is again, like it is similar, like these are all installed products, and then on the fly, I cannot do this kind of installation based products. I cannot run it on 750 hosts, and then there are a lot of bugs, and then also really limited. It depends on your patches. Not all the patches are eligible, and then there are some customizations here also. Like some of the orchestration it does on its own, like stopping the services, stopping the databases. Some of it is done, but not many customizations, right? So if you are really concerned about the downtime and your architecture is complex and need some feedback, so this is not the tool for it. So this is a tip I can give you. So basically, so you might have come across several articles explaining online grid infrastructure patching starting policy. So this is the key. So, and this is wrapped into several products actually. And all of those products use this one in the backend. So basically, once the grid setup tool is run, the root.sh, there are options to basically switch to the new home without even shutting down the existing home, right? So that is basically zero downtime grid patching, not the database home, but grid patching. You still need to shut down the database for switching the RDBMS binaries. But for grid, at least if you have a one-off patch or something, this can be leveraged. But the biggest limitation here again is, so if there are any patches specific to ACFS or OS kernel module patches or something like that related to OS side and grid, and then something related to ACFS drivers, which is packed into the grid. So this option, what it does is it will still switch to the new binaries, but those new patches will not be effective. They're not effective, right? So they're just you are basically running without those patches. So that is a problem, right? So not for every patch, and then specifically for us, definitely not for us, because our gold image consists of lot of fixes, right? So maybe one of patches it might be a candidate, but if you have a lot of fixes, definitely we have like hundreds of fixes in our gold image, and then a lot of them are not a candidate for this. Okay, yeah, probably I'll continue with few more things, and then we can open it for questions. Um, so the next one is RHP FPP, formerly RHP, Rapid Home Provisioning, and then now it is FPP. It is a big product. So what it does is it uses all those products, Oracle products, whichever I mentioned, like grid setup or clone or anything. So since this being Oracle product, it can leverage all those products and then do central orchestration for you. So Oracle clearly acknowledged the need of central uh, product, right? So if you are handling with hundreds of database hosts, we need something central. You cannot do one at a time. You need something for your gold image repository. They came up with this product. So this is promising and it will work for many of you. It has a lot of limitations. I'll talk about it, but for some of you, it may not work. So the biggest selling point here is it is central. It has all the goldimage is a repository, and then it is aware of Oracle products, right? So if you take any other product, or if you develop your product, probably it doesn't know what is grid, what is Oracle, DBMS, what is golden gate, things like that are not aware for external products. But this being Oracle product, it is aware of all those products. Now, some of the things which are challenging with this product are obviously some limitations are it needs an agent. The deployment is not out of the box or straightforward. Like if you come with 100 new database hosts tomorrow, you need to add all of them as clients. There is a big setup for that. You need to maintain RHP servers. There is a installation for that, and you need to maintain that. And obviously, there are a lot of bugs and product enhancements. There are a lot of limitations. And again, like if you want to tweak a small thing in this, it will take obviously months, years, right? So, which is not scalable. There is provision for running pre-patch scripts and post-patch scripts. So basically, uh, as I mentioned before, in our environment, moving the services and stopping the killing the connections, or basically draining the connections, it should be non-disruptive, and it should be intelligent. Basically, what I mean is, uh, it also depends on other cluster traffic patterns, right? So as I mentioned, like in a family, we have multiple clusters. So whole environment awareness should be there for us if we want to try. So that kind of sophistication is not there, obviously impossible. And especially there is customization is really less. There is some provision for running uh, SQL scripts or shell scripts. There is a provision, but like that is like very limited. Maybe you can add one script here and there, but not orchestration, not decision making, and all of that is not there. And another problem is probably for many of you, it might not work. Like if you have a basically a client without the RHP client, right? So basically, if I have a target database, ideally we need to Oracle expect us to install the client. Even if you don't install the client, you can still use it for patching, but then you need to provide the root credentials when you are interacting with the client. There are some options like credential stores and all, but the authentication, communication is unique, and you have to be really careful there and evaluate for your environment. If you have any specific audit requirements around your authentication, and then the port usage and all of that, so there are something you need to look into. So those are the security limitations you need to look into. But overall, for us, like not so flexible, maintenance overhead, not product agnostic, right? So we mentioned earlier, like we are looking into multiple products in the end. At the end of the day, probably we may only look at some RDBMS. So it should be universal, right? So we don't want something very specific to a particular product and then which may not work later. So now that is the reason. So now the custom patching I mentioned. So what I mean by custom patching is, so this is something what we do is something in between Opatch, Auto, and then grid setup tool I mentioned, right? So basically we patch our test system, and then we create the full gold image. Like unlike grid setup gold image that only packs the binaries, we create the full gold image, meaning like we just tar the software location, right? So we exclude some files and all of that. And then the trick is we take that to the target system, and then we clone with our own scripts, right? So the cloning is essentially copying the configuration files from the target host, right? So existing configuration files. So RDBMS configuration files are limited other than TNS names, network admin. There are not many directories within the software home that is having like configuration files. In case of CRS, there are some, these are the configuration files, some of them. Again, it really varies depending on your environment. And then we closely are in touch with Oracle to make sure like the configuration file location changes are communicated to us and this process still holds. So if you are trying this, we have to collaborate with Oracle and make sure like you are really aware of their software structure, like internals of the software structure, where they are maintaining the configuration files and all of that, right? And then if there is anything we need to retain, we'll just from the new home, we'll again exclude that, right? So basically, we take the gold image to the target, we copy the configuration files, and then we relink the binaries, and then that's it. So that is our method. So again, like this, we are constantly watching this space. So this can change anytime. And then we are also inclined to use other tools Oracle may come up with in future and are also in currently. But basically, this is the crux of the patch. So tomorrow, if it changes, we change the crux of the uh, patching maintenance. Uh, but overall, orchestration needs are still there, right? So overall, we still want to make sure like our overall maintenance time is limited. Now I'll touch upon these things. Like now we discussed rack rolling patching, and I mentioned like each of our database cluster is a rack database. So we leverage rolling patching. So that meaning like we patch one at a time, one node at a time, wherever possible. In some cases, we cut over to the new patched database altogether. I will talk about that in a minute. Um, Otherwise, we do one node at a time, right? So here are some of the configurations we engineered over the years in collaboration with Oracle, and this might be useful. So I'm sharing it with you guys. So basically, when you're doing rolling patching, there is a reconfiguration. So reconfiguration is basically, and again, like this depends on your environment, right? So we don't use dynamic remastering, and this is out of the scope, but just to give you a high level picture. So basically, we don't have DRM, and then when there is a rolling patching during the instance startup and instance shutdown, there is a freeze of a few seconds, right? So this is how we reduced it over the time. So now we used to have 50, 60 seconds to start with in the original days of 11G without much of the optimizations and changes. Now, over the period of time, we came down to 20 seconds. This is 11G optimized, and then 19C it is reduced further because we have been giving this feedback to Oracle, and Oracle is also collecting a lot of feedback from the customers in this space. Because for a lot of the financial clients, and then for the clients where downtime matters, this is one of the pain points because you take the default like 60 seconds of down time while start shutting down and starting up, multiplied by 4 for 4 instances is like 4 or 5 minutes of downtime, which we cannot have. Yeah, so these are the considerations. And then some of the things you can do is you can shrink the buffer cache, you can increase the LMS processes to improve this reconfiguration effect, right? So this is a topic in itself, but basically while doing the rolling patching, these are some of the things we do to maintain the high availability. So now what we are doing. So now we spoke about everything. So now we spoke about types of patching. And I mentioned like we are using our own patching method and we are open to that in future, right? So anytime we can change that, Oracle can change that. So it has to be platform and product agnostic, and then it has to be scalable. And so we are having a lot of maintenances. So all of that we need to address. So for that, we developed this Ansible-based patching automation tool. So if you guys are familiar with Ansible, Ansible is basically a DevOps method to handle particular tasks at scale, right? So it takes like the hosts as input and then performs uh, tasks in the playbook, right? So basically, just as a snippet, this is something I provided here. So like I have like 20 tasks here, right? So this is a snippet, just a subset of what we do. So basically, if you see here, these are all the additional things which are products, outside products or Oracle products cannot handle it, right? So basically, host readiness is something I mentioned. Like you need to understand, like if the host is ready to patch, not only from the local cluster perspective, but also from the whole family perspective. If there is any other maintenance going on any other uh, database cluster, probably this database cluster is not ready because we don't have enough capacity, right? So these are all manual intelligence, like whatever we learned over the years. So we need to feed that intelligence to our product, right? So that is where we need this custom orchestration or custom patching method, patching product. So few things I will highlight here. So again, like there are like 20 to 30 tasks here, but again, the core of it is basically stopping the services. It can be golden gate, it can be RDBMS or anything, even the gold, anything on the database server, and then do the patch, right? So now doing the patching, as I said, I mentioned few methods. Probably we can use our own method, or we can use Opatch Auto, or we can use any other thing. But this is our orchestration layer, and then we run these tasks on your target cluster accordingly. Now, as you can see, these are again like simplified algorithm, and the point I would like to highlight here is so it has to be foolproof. We don't want any false positives. Just without product being autonomous, it should not go and shut down when there is something happening, or it should not go and cause an outage when the host is not ready for the maintenance, right? So all of those checks are in place, and we also leverage our own internal products to make these decisions. And also we are logging uh, the output of each and every task of this. In future, probably we can let machines learn and make decisions, right? So with some machine learning algorithms in the future, while we are collecting these thousands of database patching maintenance related logs, we can make those decisions. So now we are logging those in our repositories. And it can do, and in the end, we also do OS patching. And in the future, we have some accelerator systems. Accelerator has some for self-server patching. Oracle provided some tools again, but again, like putting this all together so that so instead of DBA stopping services and doing patching and then finding S3 and asking him to do uh, like this manual interaction is avoided, right? So we can do OS patching and self-server patching as part of this. So this is what it is. As I mentioned, it has to be platform agnostic, and it is driven by facts provided by us at this point, and maybe in future based on the data we provide, and let the program learn on its own and make decisions. And then it is extremely scalable. Anyone knows Ansible knows, like if I set up 3, 4 Ansible servers, I can handle like hundreds of database servers parallelly. So, and then all the tasks and the product itself is idempotent. Like if you restart, it should work, it works. And then all the principles are there within each and every script of this product. Easy onboarding. This is another biggest point, right? So there is nothing required. All you need is a Linux system. And then this is agentless. You don't need any agent on the target. You don't need anything on the host, on the server. There is no concept of agent. So it is ready to use. Whenever you have a server, it is ready to use. In architecture awareness, as I said, like it is, the product is aware of everything happening across and within. So this is like our FreeCon log. FreeCon is our performance metric log. And just as an example, like this leverages this and makes the decision. So zero downtime patching. So now we talk about rolling patching and then downtime involved within the rolling patching due to reconfiguration, right? So we don't have DRM because we don't want any unplanned outages. So so if you take 4-node cluster, even with 20 seconds of reconfiguration time, we are looking at like 20 seconds while going up or 20 seconds while coming down. And then for 4 nodes, it is like 2 minutes of downtime or 3 minutes of downtime, which we cannot take in many tier 1 database use cases, or tier 1 meaning like any payment impacting database use cases. So for that, we have this Golden Gate based cutover product. So at high level, what it does is you have a local copy, right? And then this is based on Golden Gate. Uh, uh, in the beginning, this copy is active, right? So one of the copies is active and the other one is taking the changes fed by the live database or SOR database. As John mentioned before, SOR is a system source of record. So, so as part of this cutover, what we do is we don't deal with individual nodes. We patch this target cluster right? So where there's no traffic on this cluster. So we patch this target cluster altogether and keep it ready. And then we switch the traffic from source to target. So this is all automated. Just at high level, I would like to mention like what we do here. So we switch the database services onto the target database, and then we stop the connections and then drain the connections. We make sure there's no lag, golden gate lag, replication lag, and then we do some bunch of validations and open it up. So all of this happens within 30 seconds. We have great success with this, and we were able to do a lot of cutovers within 30 seconds, since all of this is automated. So we also do leverage this method for all payment impacting databases. So I think I took some more time, so I would stop here. I think probably there might be some questions. You guys can go ahead and ask any questions if you have.
Yeah, thanks, Pramod, for a nice session on patching. The golden thumb rule is never ever interrupt a patch. So that's why we didn't interrupt you and we allowed you to continue to the finish. So there are a few questions that was answered by Samrat. If you want to glance through it and talk about it, that would be good. And for all the attendees, feel free to raise your hand so that we can allow you to talk and you can interact with the speakers and other panelists.
Yeah, some of the questions I see Samrat answered. Thank you, Samrat. And do you apply RU, RUR, or combination? So yeah, he mentioned it. It is RU plus people fixes. So DB shutdown. Okay, I think that is also answered. Okay, so yeah, if you guys have any other questions, you can ask now directly or via chat.
Yes, hi. Do you hear me?
Yeah,
Yes,
Kamran,
Kamran, go ahead.
Yes, hi. My name is Cameron. You might have mentioned that during your session. It was a very good session, by the way. Thank you. And I was going to say that generally, how much of Oracle guideline for patch install do you use in reference to your own functionality improvement and functionality fixes? And so, and what is the flexibility in between as far as the scheduling of the patches?
Right. So what we try to do is, obviously there are a few types of fixes, right? So some fixes are like hot fixes, meaning like there is an impact, there is a bug, and then that is impacting our system. So for that, obviously we have to apply them immediately. So then we refresh our gold image and try to deploy it. And for other functionality fixes and enhancement requests, so our process over the years is we constantly look into areas of improvement, and then we get these enhancement requests from several people across the organizations. Like few people, a lot of our colleagues work in great areas, and they have their own recommendations, and then Oracle may release patches accordingly. And again, like this is a collaboration, basically based on your collaboration with Oracle, but we do include all of those fixes in the quarterly manner whenever we get quarterly patch, and that is where we would like to include it. So basically, whenever we deploy our next gold image, that is when we include those patches, unless they're urgent. So it is anywhere roughly like quarterly to half yearly. Hope that answered your question.
Yes, thank you very much.
Okay, thanks.
Pramod, there is a question. What is the downtime with this automation?
Okay, so now I think we are talking about, there are two automations we mentioned. So one is Golden Gate based cutover. So that is basically cutting over across the clusters. So the downtime here depends on several factors, like the number of connections on your system, and then how faster you are killing the connections, and then validation